There probably are some charts.
So I just had a little flash here. The 0-1 computer system that is, most of it's based on is kind of like in the mode duality. It's this or that, off or on. When you base it on 3 and 9, it
3, 9, and 6.
Yeah, 3, 9, and 6. It creates a current that doesn't stop because it's more harmonic.
3, 9, and 6 obsolete. 0 and 1 doesn't even exist. They think it exists, and they think they're making it work. Take his question. Okay. Say his question real loud one more time while I look for the chart.
Let's see, when the new computers start using this tertiary system of what, 3, 6, and 9, would they be able to be imaginative and creative as we are?
Here we go, we found it.
What a question.
Wow, what a thing.
Great question.
They already came.
Artificial intelligence. Ad infinitum magnification. The toroid is recursive. Okay. Quantum mechanical effects can be duplicated on a macroscopic level utilizing this toroidal model process. Okay. Underlying coherence. Artificial intelligence. Using the triaciary system that you said. So let's see how it works. Okay. A fractal, would a fractal, Judy, you mentioned a fractal. Would a fractal be artificial intelligence? Because it's self-similar. It duplicates itself from micro to macro.
So, and it has an element of novelty. So I'd say it is.
Let's say artificial intelligence, let's start defining artificial intelligence. Let's say that, first of all, artificial intelligence is the fact that we have a fountain here, and it's making a little water vortex. Okay? But we have a tornado, and it's the same intelligence, but on a bigger scale, a vortex. And let's say we have a solar system, which is our galaxy and our planets and the suns, and they're spiraling in a spiral of a vortex. Would that be artificial intelligence? One definition? That it can be the same principle from small to big, big to small. Okay? And we do know that those three knowledges were the same. So let's look and see if this does the same principle. Though won't be too easy, but here are 7 times 7, 49 tiles. It's the same tiles. 1, 2, I think I better show it here.
But well,
That's not on our own.
Got to start way up there.
That's the knowledge, and that's the unknown.
Okay. Remember the pattern that really made this? We did the multiplication series and everything, but really the most important thing, I think, is these doubling circuits and the 396, 39, and the, okay, everyone follow me? So we have two things, the doubling circuits and the 396, 693. Really three things.
But well,
That's not on our own.
Got to start way up there.
That's the knowledge, and that's the unknown.
Okay. Remember the pattern that really made this? We did the multiplication series and everything, but really the most important thing, I think, is these doubling circuits and the 396, 39, and the, okay, everyone follow me? So we have two things, the doubling circuits and the 396, 693. Really three things, but I'm just lumping the doubling circuits together. Okay. So and remember it's going 1, 2, 4, 8, 7, 5, and it's making this pattern over and over again. Okay, I think this will be kind of fun. Okay. So I'm going to draw. It's kind of hard for me to do. How many have I done there? Okay. Okay. I need blue. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. There's only above the third dimensions on my fourth dimension. There's no 6, 7, 8, 9 dimensions. Now on my dimension is the 9, and the fourth is the 3 and 6 are the fourth dimension, which represent magnetism. 3 and 6 is magnetism. The 1, 2, 4, 8, 7, 5 represent electricity. In between the 1, 2, 4, 8, 7, 5, you always have the 3 and 6, which is the magnetism. And in between the 3 and 6, you always have the 9, which is the theta particle, the ether flux, the spirit. As far as making things and doing things, though, in artificial intelligence and stuff like that, I really cannot comprehend anything that cannot be done using this. Okay. So let's take a look at what we're doing with 5 boxes. This was the number 5 was right in the middle. We had 5 like that, correct? 5 was on the inside. Okay. So we come down 5 now. We're going in odd amounts. 1, 2, 3, 4, 5. So we come down 5. Okay. And where's 1, 2, 3, 4, 5? So this was it right here?
Yeah.
Okay. And what's the number in the center? Well, that's exactly what belongs. Because and what's going to be if there's a 5 there and a 7 there? There's going to be, no, there's got to be an 8. Because 8 doubled is 7, 7 doubled is 14, which is 5. So sure enough, we count down 5. Okay, is that 5? 2, hope so. Okay. And what's the number in the center? Okay. And what's the number between 4 and 8? A 4? Well, did I do it right? 7, 1, 2, 3, 4, 5, 8. 8, 7, 5. So there's got to be a 4.
All right, the red 4 down the red 4.
Right, so it's 4 down there.
Okay, but it should be 5 away. Why not?
It is.
Well, because
It
it's
is.
the 1.
Oh, it is. 1, 2, 3, 4, 5.
Yeah.
Oh, yeah. Hey, that's pretty heavy duty.
I like it when he's surprised. Yeah, it's like his invention. And
So the center numbers are moving
Uh-huh.
by that. That's right. The centers are moving.
It's still alive.
yes.
And if you just
What are you saying, Charlie? Say it real loud.
the center numbers are moving according to our circuit, aren't they?
Well, if you do the one right over next, the not only the center numbers, the circuit, which are the doubling circuits. What about the 396, 693? So actually have the pattern, which is this it here?
5, 7.
So we'll do right here 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and then the center one.
That's
So
not-
I took it off by 2. I staggered them.
yeah.
1, 2, 3, 4, 5. So it's kind of confusing. So right now we've got another doubling circuit going in the reverse direction. And if we go over here, we'll have the 396, 693, which will be... Okay, it's kind of hard to do. Oh, here it is.
Right?
Okay, so here we have a 6, right?
Jackfruit even.
And it goes like this. Oh yeah, that's called phyllotaxis in plants. It's the same pattern. And here's a 9. 1, 2, 3, 4, 5. It's making the whole thing with the spaces
Right,
and
so
everything.
That's the self-similarity appearing, isn't it?
Exactly.
And you could do that with 6. You could do that with grids of 6, couldn't you?
No.
You couldn't. So you chose groups of 5 on the
Because
side, right?
we've already covered groups of 3,
Right.
and we haven't covered groups of 2, but every one that we choose has another wisdom.